the freezing point of a 1 molal solution of a non-volatile solute decreases by a constant amount for a given solvent. So basically, freezing point depression deals with a solute and a solvent. And by adding the solute to the solvent's freezing point decreases. So if you take water, for example, it freezes at 0.0 degrees Celsius. So that water is a solvent because you put things into water for them to dissolve in it. Like sugar is a solute which goes into water and dissolves. So water's the solvent. It's what makes other things dissolve. Now if you add a solute to the water, it has the potential to make the freezing point depress or go lower. And so then the freezing point of water will be negative something. So that's what we're looking at here. We're adding sodium chloride to the water, and the sodium chloride is a solute. And so the sodium chloride, the solute, and the solvent, water, forms a solution. And so now we're wondering what the freezing point is going to be because the sodium chloride is going to cause freezing point depression. And we call this an aqueous solution because there's water involved, so the solution is going to be liquid. All right, so the equation we use is this one right here. So it obviously has two parts. So the first part is the freezing point depression. And then the second part is made up of Kf, which is the molal freezing point constant. And then we have M, which is molality. So now what we need to do is go ahead and start looking at what we already have and then plugging those things into the equation. So we know that the molality of sodium chloride is 1.5 molal. The Kf for water is negative 1.86 degrees Celsius over molal. And the freezing point of water is 0.0 degrees Celsius. So we can go ahead and begin to plug this into our equations. So what we're looking for here is the freezing point of the solution. Basically, after everything's combined, the sodium chloride and the water, we're wondering what the final freezing point is going to be. So first, though, we need to know just what the freezing point of sodium chloride is, and then we'll go from there. So we can go ahead and plug in Kf, which is negative 1.86 degrees Celsius over molal. Then we can multiply that by 1.5 molal. Before we calculate anything, we already know that M and M are going to cross out because M is in the denominator here and in the numerator here, so those can cross out. And then we know what the freezing point of water is, but we're not going to use that yet. We're going to go ahead and calculate this. I'll save you that step. So the answer is going to be negative 2.79 degrees Celsius because M and M are crossing out. So we're left with degrees Celsius. So now we're going to take the freezing point of water, which is 0.0 degrees Celsius, and add it to negative 2.79 degrees Celsius, which, remember, is the freezing point depression. In other words, that's how much sodium chloride is going to cause the freezing point to depress. So we add those together. And so this equation, or the answer to this equation, is pretty obvious, but we still need to work through it. So this is the answer to the equation. This is the freezing point of the solution in water. Because remember, we were looking at this right here. What is the freezing point of a 1.5 molal sodium chloride solution of water? And the freezing point is negative 2.79 degrees Celsius. Because this negative 2.79 degrees Celsius right here is the freezing point depression. And so it just so happens that since we're starting with a freezing point of 0 degrees, that the freezing point depression and the freezing point of the whole solution are the same number.